So we're going to do number 18. I'm not going to do all three. By the time we do 18 and we think about our steps and we think very carefully about our step, then we should be able to get the rest. So 18 says when you reverse the digits in a certain two-digit number, you decrease its value by 45. What is the number if the sum of its digits is 5? So whenever I see a reverse problem, now I don't ever like to tell you steps to do a certain type of word problem for the most part. I don't like that. I want it to be a problem-solving thing. This is so, in a way, bizarre that I am going to kind of give you the thought process. You don't have to do every step like I do, but I want you to have the thought process because I want you not only to be able to do a problem like 18, but one that might be similar to it, right? So it's more important to me that you understand the thought process rather than a series of steps. So the first thing we talked about when we did our model is setting up our variables. And on a problem like this, it says it's a two-digit number. So if I'm going to draw a picture of a two-digit, I love pictures. Like, I can't draw all, right? But I do like pictures. I have a two-digit number. And all I know about two digits is one is the tens and one is the ones place. I know that's true about a two-digit number, right? So I'm going to set my variables up accordingly. T is going to equal the tens place. And n is going to equal the ones place. And why did I not use O? Because it makes it look like a 0. Could you have used x and y here? Absolutely. You just need to be able to define them because I can't tell you how many times students get to the end and they can't remember which one was x and which one was y. And if you do that, you just got the problem completely wrong. My students will say, oh, but the answer was 54, I put down 45. Yeah, that's bad. But it's the same digits, just reversed. Yeah, that's like the bridge would have held up if I just reversed the digits. But now a family of 5 is dead. That's not what you want, right? So it has consequences. Now, when I do these, I'm looking, and this first one is super easy to me. What is the number if the sum of its digits is 5? So for my first equation, every system we're doing right now has two variables and two equations, right? A system can have multiple, you can have more than two, but we're dealing with two right now. So t plus n must equal 5. And I put a little 1 there to remind me that's the first equation. Circle it or something. You don't want it to think it's actually a number from the problem, right? You might even say first. Whatever it takes so you know. But if you're struggling with these, identifying your first and second equation will help you later. All right? Now the second one is causing me to do a little thought bubble because it talks about the number reversed. So in order to understand the number reversed and the original number, I'm going to do a little thought thing here because I don't want to just remember a formula for something so obscure, but I want to be able to remember how I get back to there. So here's my original, here's my reversed. And I'm going to make up a number here. And the reason I'm making up a number is so that I understand how it would work with the variables, right? So if my number was 72, and I wanted to show the value of that number, I can't do t plus n. That's going to give me 9. So that's not going to work. So what would equal this number in variables? It would be 10 times whatever my tens place number is, right? That gives me the value of 70 plus n, or 1 times n, which would give me my ones place. Does everyone see that? So again, I had to do that because think about it. So if my numbers were 7 and n, it'd be 10 times 7, which is 70, plus n would equal that number. This is how I show my original number when I have two digits of place value. Now, when we do reversed, I still am using the same variables. So looking at this made-up example I gave of 72, the number would be 27. Well, if I did 10t plus 2 again, I'm still going to get 72. So if I'm reversing it, algebraically, what am I doing? I'm multiplying the ones place by n, not the tens place. And see how I put a real number here so I made sure it worked? So now let's try that. Well, 10 times n would be 70, yep, right? I'm sorry, 10 times n would be 20, plus 7, 27. It still works. From my original number even, right? Because this was n, this was t. Is everyone good with our setup then up to this point? And this is my reverse number, just like the reverse flash. If you are not watching the Flash, shame on you. It's one of the best programs next to Empire on TV right now. We do not laugh at Empire. All right. Once I've done this, it makes the understanding of number 18 a lot better. It says when you reverse a number, you decrease its original value. Its value can say original by 45. So guys, when you do that, the first thing I would do is I would put the 10t plus n, that's my original, that's on one side of the equation. I'm going to leave room because I don't know where I'm adding or subtracting yet. All right? And on the other side is my reverse. All right? Now let's look really carefully at what this is saying. It's saying when I reverse it, that reverse value is 45 more than the other, right? Or it says it decreased the original by how much? So this was my original, and when I reverse it, this is reversed by itself, I decrease the original by 45. So whatever my original number was, the reverse number is 45 less. Yes. You could have easily added 45 to the other side and still got the right answer. And that's why I kind of said it both ways. Good follow-up. I think it depends on how you see it. What you couldn't have done was subtract 45 over here. All right? This was my second equation. You must be able to set these up. On a quiz or a test, I will give you no credit if I do not see both equations. Y'all are very smart. I know you can figure out the number sooner or later by the clues. I need you to understand how to do it by the system. All right? Now from there, let's talk about solving the system. And from there, the only reason I'm starting over on a new paper with the new equations is that was all colored to understand the setup. From the setup, you just have to solve the system. T plus n equals 5, my first equation. My second equation was 10t plus n minus 45 equals 10n plus t. That is the most awful looking equation I have seen in my life. I am going to make it look a lot better. Right? I wish I had the ability to memorize on paper. So, I think you can do this either way. I'm going to save myself a step, and I am going to, you have so many different options. For me, I'm going to start by adding 45 to each side, because I want I see over here my variables are on one side, my numbers are on the other. And so that's going to give me 10t plus n equals 10n plus t plus 45. All right. You see why I use a cursive T? And I'm writing a 2 here to remind myself that everything I'm doing right now only has to do with my second equation. Some of you get lost at what you're doing and what it relates to. Then, for me, I would subtract 10n minus t on both sides. And that's going to give me 9t minus 9n equals 45. This is equation 2 that I just rewrote. I'm going to rewrite equation 1 because it's all the way up there, and I'm going to get confused on which line I'm doing. Some of you may not. All right? I've got one of my best students look up there like, oh my God, you're not going to make me rewrite it, are you? No, you've got 101 hours in your life. I'm going to rewrite it because I'm not so great at these, and I don't want to get confused at what I'm doing. From here, the method you choose is up to you. I would probably just do elimination. But it'd be super easy to do substitution as well. But for me, I can easily just multiply by 9. and add straight up and down. So that's going to give me 18t equals 90. Divide by 18. And t is going to equal 5. Then I can go back to either equation. Well, that one's super easy. If t is 5, what does n have to be? 0. Because 5 plus 0 is the only thing that gives you 5. So my number is 50. That's your answer. And now I'm going to go back, because I'm smarter enough to know that I better go back and make sure that this works with the problem they gave me, right? So I'm going to go back and look, and it says when you reverse the numbers into certain digits, you decrease its value by 45. Well, 50 reversed is 5. Is that decreasing it by 45? Yeah. And the second thing says that add it together, and it should be 5. If I add up 5 and 0, is that 5? Yes.